Okay, we're going to go into a deeper understanding of four-phase power, our superconductive grid. What you're looking at is the Bose-Einstein condensate above room temperature. You're welcome. So we have a lot of things to go over here based on lithium ion and what we're going to be doing in the world of lithium ion batteries, converting the carbon in lithium ion batteries to graphene in the electrode and in the lithium matrix. So this is going to be science time. Be prepared. We're going to briefly go over Cooper pairs, Puck-to-Cooper chains, the tunneling effect of carbon and graphene, the understanding of the three phases of superconductivity. We're going to briefly rediscuss the Zohm tool, the understanding of the components that you can purchase to do proper fractal geometry so that you can understand the bow tie of superconductivity a little bit deeper, and the Meissner effect, the magnetic moment, and the tunneling effect that you see in the bow tie of superconductivity in the previous videos, and the tunneling right there and right there of the Cooper-Puck chains of superconductivity above room temperature. We are amplifying superconductivity. We're going to talk about a rule that I am breaking. I am breaking a laboratory rule. The rule is plagiarized that I do not eat, drink, or smoke anything that I produce in my lab. We are breaking that rule today. So what I want to show you is something that you need to see. Harmonics. This generator is perfectly harmonic at 60, minus 60, 67, 72 decibels, pinging just about 67 decibels, even with the chain. That's exactly tied to our voltage. The reason this is important in Planck is the phonon and photon resonance of the biology. Superconductivity and fusion are a biological event that is beneficial for our bodies. So we're going to be doing a very important cold open test on a lithium ion battery in a phone to see if this energy will charge a lithium ion battery without blowing up that battery. Now, I will tell you a disclosure. I was in the board meeting with Boeing, with the turbine manufacturers, with FedEx, right after the jet caught fire using lithium ion batteries. I brought them to their attention that my grandfather is a turbine builder for Boeing, retired. The turbines are titanium #2, no oxygen, the perfect turbine to conduct environmental energy. When the turbine goes through the cloud, it superimposes a high frequency over the chassis of the airplane. They tried to use lithium ion batteries. It exploded the batteries because they had nowhere to dump the charge. They were shunting the charge like happens in these batteries to regulate them, to turn them on and off, and how all of them. But I told them you need to dump that load into the chassis of the airplane. I fixed their problem. We know what we're doing. We're going to be supercharging a Tesla Roadster. Last thing I want to do is turn that thing into a flare. Look at lithium reaction in water. Lithium is made by brine. There's always a certain amount of water. I apologize, but I cannot remember the name of the detritus that happens in lithium ion batteries, but they're little trees of carbon nanotubes that grow from one electrode to the other and effectively kills your battery, shunts it, okay? And if it goes too fast, they'll fire the battery off and burn it up in your pocket or wherever, okay? So we're doing a safety video. So we're gonna take a dead phone, The steel is my heat sink in case it goes viral. I'm on top of a piece of sintered ceramic that can easily take that ferrite, ceramic ferrite, can easily take 6,000 degrees. I'm on top of a piece of metal plate, on top of a granite block, so that we have an even temperature distribution, and it's been sitting like this all day long, and everything's been running all day long for at least 10 hours. So we know we have a very accurate heat soak. Then I'm on top of this piece of ceramic that can easily handle 10,000 degrees. And I'm putting this phone that I can't use anymore because it's got a cracked screen, but it does charge. I don't care about it. I'll sacrifice this for science. Then I have this Pyrex that can easily handle the temperature of the flame because we want to see it. This is science. So we don't know. I don't know. Ladies and gentlemen, I tell you specifically everything as fact. But when I don't know something, I will specifically tell you I don't know. This is a cold open video in the heritage of Saturday Night Live. I have no idea what's going to happen. So we know that there's that. This is my old phone. It has 79% charge, but only 10 hours left. That's a dead battery. I know that. That's why I got a new phone that you're viewing on. This phone, or the pad, is 41%, but it has 20 hours. So this is a good battery. These two are identical. I've got two chargers. This phone was dead earlier with 3%, so it's been charging. Okay? These chargers, we know if they overheat, they catch houses on fire. So this is the grid. This is the 4-phase power, the self-regulating. Okay? This is not on. When this plug is energized via this light will come on, and it's plugged in to the generator. Okay? We're going slow for safety. In a moment, we're going to come back to this and take temperature readings before we push the switch. But I want to show you something. This is, hold on, I'll do this one more time. This is this. You see that little spark right there? That's the bow tie of superconductivity. That's the energy coming out that would normally give you the Meissner effect. That's how strong my tunneling is. It's not just at the cross of the bow tie of superconductivity. It's past the Meissner effect, proving that the energy is tunneling through the carbon in the wire, and the graphene is supercharging it like a revolving door. Once again, these are copper crystalline structures based on fractal geometry all the way down to the atomic level. This is carbon 12. The protons and the neutrons are balanced. The electrons are balanced with 2 on the inner shell and 4 on the outer shell. When you cool down something in superconductivity, the carbon opens up to graphene. When you go a little colder, the wave goes into a Bose-Einstein condensate. There's not very many people that can upset and debunk Einstein's 2 basic theories. That one and MC squared. Everything else is bullshit. Theory. Here is, I'm an applied physicist. The truth. This is the bow tie of superconductivity. Check this out. 60 volts, 60 hertz, slow, safe. The generator, 42 degrees. This is a polyphase, regular old, run-of-the-mill wiring with some tight hysteresis. Okay? This is not a custom generator. It's custom built and custom designed. There's no question about that. but the polyphase AC generator concept is in here. All we did was change the magnetic moment of the neodymium magnet and change the copper carbon 12 into copper graphene. That's it, by opening up the column bond. Now it's set. I'm disconnected from, and this is all the power we needed to do it right here. That's it. Okay? Check this out. The temperature sensor is inside of my lunch. It's been sitting there since 12 o'clock. I think it's 10 o'clock now. Okay? The inside is 218 degrees. Hot enough to cook your food, hot enough to kill bacteria, but not hot enough to boil the water. So the juices are still in there. But that's not what's cool. This is cool. Look at the outside temperature of the aluminum. 64 degrees. I can touch it. Because we're at the atomic level of this energy, imposing a perfect radiant heat to your cooktops. But look at this. Look at my coil. 360 degrees. That should have been turbo toast by now. It's a carne asada, not carne asada, it's a machaca burrito. Look at that. Okay? Yeah, we can still char it a little bit because it's been sitting there all day. But the moisture, look at the steam coming off it. It's still there because it hasn't boiled off. It's still going to be nice and smooth inside. So, contrary to what I thought, yeah, you could possibly burn some food. But, watch this. Here is the cooktop. They're all evenly on the same power. They all have the same ohms. They started at 14.9, but now they're 14.2 ohms. And so we changed the resistance in the annealed metal of your cooktop. So it still gets hot, but does it more efficiently. So there's 200 degrees, 295 degrees. You come up here and it's only 183 degrees, okay? But the water, the tea, is 134. I apologize, I missed it last night. These are the tea bags from the last time. So the last tea, which is chamomile, was completely rich and dark. Now look, I'm seeping out of the same tea bags. You would not be touching this on your cooktop. Look, no problem. Absolutely no problem. Now we move over here. We're doing 2.5 amps. So we're being cautious. Jump over here. Look at the cooktop. Now look at the coffee mug. Okay? Now look at the coffee on the inside. Same coffee we boiled last night, 120. Look at the handle. Watch this. Doo-doo. Cold as day. Room temperature. No problem. Try that at home. Try that in a microwave. We're back to my little fish. I don't like fish, so we're cooking this one. Look at the temperature gradient on the fish. This metal, paint, glazing, copper, 105. This metal glazing, give me a second. Let me start this again. This glazing, 108. This glazing, 115. Come out here, 83. This is a piece of ceramic. We use ceramic so we don't get hot spots. But look, I can pick it up. No problem. Yeah, and it's relatively cool. It's the steam that's heating it from the coffee. Interesting. Now we have perfect resonant cooking. On the simplified understanding, please understand who Dale Pond is. He is the king of sympathetic vibrations in nature. We all know, if you look around all the yandra of the health, oh, vibrations and this and that, Dale Pond is the king. We are emphasizing the importance of the electromagnetic grid that is technically killing you. I'm sorry to say it that way. I am not a doctor. It's not a medical claim. It's a fact. Hypothetically, truthfully, if your food is prepared properly at the atomic level, you're going to be correct at the atomic level. We already know the hydrotherapy on proton spin technology under these same principles is definitely cancer preventative and definitely puts people in a better feeling after chemotherapy. Let the doctors tell you that on proton spin technology or the Irvine Center for New Medicine, who are registered doctors in cancer. I'm not going to tell you that. We just built the systems. Okay, now on to the fun stuff. I have no idea. I have absolutely no idea. So we decided to be safe. I have my safety glasses, okay? I should be wearing a welder's helmet, but you know what? Throw it up to science. My clothes are damp, okay, just in case. We have a fire extinguisher, but I want you to notice something. I purposely did not wipe the dust off the fire extinguisher because we take safety very seriously, okay? It does not get used unless we need it. The dust is the testament. Okay, here we go. I have no idea. The LEDs in the screen are, give me 1 second. Yeah, I like blue. The LEDs in the screen burn your eyes. In a moment, we're going to hook up that meter to get a base load. Okay? That's a light intensity meter on that meter. Watch the LED from the laser. You can't see it on the screen because it's canceled out by the LEDs. Well, these LEDs, they burn your retina. We know that. Hopefully, if everything goes right, we're also going to see a change in the screens of your computers and phones. So we decided to use, instead of going through a lab, we are going through a lab and spending a bunch of money on tests right away. We're going to use the calorimetry and the understanding that's built in our phones, which is pretty good. And we all kind of somewhat trust that Samsung and Sony and so forth and so on know what they're doing. Okay, here we go. Temperature 61, granite block 60, 61, little teeny power supply, and we have this. These are the hot boxes. They're like the ones you can buy from the 5 and dime, and this one's set at 3.1 amps, the worst. These things are hot boxes and they catch houses on fire. At least the ones that comes with your phone, they have a little bit better circuitry in them. But still, the one that's charging is still 70, let's get a little closer. Okay, 94, let's see what the plug looks like, 61. So they got good regulated power coming out. Let's see what the plug looks like coming into the phone. 63, okay, only a couple degrees over ambient. We're okay with that. Let's check this one. This one is 61, same as the load, so that's copacetic because it's charging. Let's check this charger. 59, 60, been sitting here undisturbed. Back to this, 94. This plug is 60 because it's just running the oscilloscope. Okay, this is running, this plug is running this big piece of equipment. That gives you an idea of the inefficiency of these things, and they're dangerous. That's why you only use UL listed ones and be very careful. Okay, batteries. All these batteries have a serial number and a QR code. Okay, so now we have a video documentary, because these are going to be our controls. These are the ones that we're going to send to Wildcat Discoveries, the lithium ion battery benchmark testing company in San Diego. These are dead batteries that were donated to me by the phone store because they're dead. That means they have these little trees growing from one electrode to the other, and they won't charge anymore. We're going to later energize these. They're pretty basic. You've got a plus and minus, and you've got 4 poles, 2 for charging, 2 for discharging. So we're gonna make a little chingasa so that we can charge these with this energy. We're not even gonna bother with electromagnetism. We're gonna take them to their lab where they can verify and look at them in their electron microscope. They'll be able to tell us if we've done anything spectacular in these batteries before we do it to the Tesla and we vape Elon Musk, because he's gonna have a hard time figuring out what we did when we send it back to him. But we're gonna tell him what we did, because he already got the email of the video on my YouTube. I know, I got a confirmation. So, sorry. But you gotta pick your... I'm the Indian, he's my doe. I'm not gonna hunt the buck, I'm hunting that little doe. Okay, just so you know, my Halloween costume is the court jester, because he's the baddest in the land. Everything seems to be a good, even temperature. Let's find out. Okay, so now you can see the reflection on the screen. It helps that it's dark. Okay, 59 degrees starting. Temperature plug, 58 degrees. All right, let's find out. Here you go. Boop, power on, light on, power's on. Phone's charging. See the little red light? Who knows? I have no idea. 59 degrees. Okay. Nothing yet. Let's touch it. Let's see if I can get it to turn on. Remember, this video is a cold open. It may take a while. I got plenty of memory. Okay, I feel a vibration. It's talking to us. You're getting sleepy. Sorry. I have a lot of fun with this energy. I've been working with it since 2006. I built my first circuit, worked the first day. I really understand this, but I also understand the dangers and the safety. So as a last resort, when the scientists can't figure something out, they usually burn it. That's why we have spectrometry. Because we're burning something into a vapor so we can study the vape. That's why I'm telling Elon Musk, vape on this. Because he's trying to figure out a 100,000 mile battery or what have you. He's already got one. My cousin, Bobby Pukta, works at the Gigafactory in Nevada. He has no idea of the industrial espionage. Even though his patents are open, just look at BioGem. He has no idea what I know about him. Sorry. Okay, we're not getting any love. So what do? We have to have a little bit more foreplay. Okay, so let's just turn up the juice. We're at 31 hertz on the drive, 60 volts, 60 hertz, and I can guarantee you it's going to be perfect power. Okay, perfect power. All I'm doing is speeding up the generator. Before, this generator used to burn up. There's the proof. At 250 RPMs. We're over that now. There's your linear Paul magnetism and revolutions. There's your bow tie of superconductivity. Now, we're still all over the world, 50% power, AC, 127 hertz, volts, 113 hertz. Normally, a high capacity discharge would destroy a lithium ion battery. But we're safe from over here, okay? So, let's check the DC. Oh, no DC override. A perfect wave. There's my Hertz DC. Where's it coming from? The bow tie of superconductivity and the Bose-Einstein condensate. There's the perfect power. So we're just gonna leave it here. We'll go to volts, just for the hell of it. Here's the temperature of the generator. This generator, at 180 degrees, it fried, okay? It ran away. It's never gotten over 140. Now I can smell my burrito. I'm still 215 on the burrito. We're gonna have coffee, tea, and meat. Now we're doing 5.2 amps. My cooktop is now 400 degrees almost instantly. I'm 480 degrees, and I'm just gonna put down the thermometer and know that I can pick up the coffee cup. Okay? I don't even have to worry about the burrito, but we're finally toasting the burrito, okay? I kind of charred the bottom, so I'm gonna flip it over so we can have some carbone. Oh, Sandra. Okay, but look at my cooktop. $400 degrees, okay? But the funny thing is, I'm touching it. Look at my paper, okay? The paper's not, it's just burned because of the burrito. Not too bad, but I can still touch it. Try that at home. I'm gonna be nice. No, I'm just gonna leave it, okay? I can deal. I'll eat the inside with a fork if I have to. No, I'm gonna eat the whole thing. We don't even know if that carbon, maybe it's graphene. I have no idea. We'll send it to the lab. Point taken. Control. These are the little pieces that you've been seeing on the electrode, right? Okay? We're gonna put those on this specific water scale that's here for a reason, because we know something about gravity. I'm able to make elements light and heavy. We're going to see if we're flipping over the pieces of metal, if there's a weight differential like we've seen before. I'm just putting that for my own mental note. Take it as you will. Okay, now back to the experiment. You see how bright the light is? It's still technically running cold. That's a 350 degree light bulb. No problem. But look at the temperature now. Running cold. Perfect resonance, using all of its power. But look at the light. It's not all washed out. It's a perfect spectrum. Okay? All right, here we go. Huh. Look at that. The charger's cool compared to this charger. And what is the spec on this charger? Give me a minute. The spec on this charger says one amp. This one's tied at 3.1 amps. So this one at 1 amp is 100 degrees. This one at 3.1 amps is room temperature. Holy shit. Or holy smoke, or whatever you want to say. Look at that. Okay, I'm good with that. Now let's take it off of IR so we don't get fooled. There's the temperature of this screen charging. Here's the temperature of this screen not charging. 68, 74. Because the heat from the battery is heating up the screen. The LEDs don't really, maybe we'll give them 1 degree. Because let's take this one. It's got no screen on, 66 degrees. Okay, 4 degrees. We're going to give the LEDs 4 degrees. Over here, there's the other 4 degrees. No, this is 68. There's 6 degrees. 6 degrees difference. That's the charging. So, you got to go back to BTUs. Mental note, feather in the hat. Now let's figure out what this bad boy is. We're going to leave it off IR. 64 degrees. The same. Oh my goodness. The same. You know what this means? This means is all we have to do is just now plug in the Tesla to the standard charge port, and it's going to change the graphene in the battery. Okay? Uh-oh, my carbone. Yep, you can still cook some pretty good food. So we're just going to take this off of here. I can pick it up, no problem. See that? I'm holding it. The internal temperature says 220 degrees. I can guarantee you, you cannot hold something that's 220 degrees. There you go. Okay. We're kind of cool with this phone situation. Let's see if we can get it to turn on. If I cannot get this phone to turn on and I don't feel any temperature, I'm going to plug it into the backup phone so we can see if the phone is actually charging or not. And then we'll plug it back into this one, okay? Because I know that this phone takes several minutes when it's dead to even get the battery indicator. But let's just do a quick check. Okay, now we're plugged into this phone and it charged. And so the charge indicator is at 77%. Let's see. Oh, look at that. Charging USB. Okay. Okay. This becomes the new control. And we'll get back to it. Let me see if I can turn this one on. It's definitely talking to us. Okay. "66, 65, 67 degrees. This phone, I'll leave it charged. I apologize, I'm going to try to do this with one hand. Actually, I'll try to do this with one hand. I'm not sure if I can, but I want to try to, I'm going to put the phone down for a second. I apologize. I wanted access to the battery. I want to know right on the battery. 67. Wow. Look at the plug for the light. Everybody knows that plug cords get a little bit warm. Ladies and gentlemen, I think I've seriously come to a conclusion that this definitely is some safe power. So what we're going to do is we're going to continue because we want to make sure this is safe power. So we're going to have to talk about something else. We're going to put the safety lid back on. We're at 77% charge. Write that down.